Creating lifelike CGI is work that I greatly admire and aspire to, but I'd be lying if I said more stylistic renders didn't speak to my heart a little bit more. Whether it's cell shading, hatching, or something completely abstract, stylistic renders are fun to make and fun to look at. And if you're going to try and replicate some of these styles, a useful thing to have in your tool belt is how to render outlines of your model. So today I'm going to show you a classic way of rendering outlines of your model using an approach called the inverse shell. So let's go ahead and get into it. So this next section is going to go a little bit into the mechanics about how the inverse shell illusion actually works. If you already know how it works or you really just don't care, go ahead and skip to the next section where I'll show you how to actually pull it off in Blender. But if you're actually curious about how it actually works at a graphical level, go ahead and stick around. So this is an example I put together to kind of illustrate how this effect is working behind the scenes. So right now we're staring directly at the cube from the camera angle and it looks pretty good. We have the nice outline, we can still see the model, and it looks exactly how we want it to. However, if we were to detach our view from the camera, but still render it from the camera view, we would see something a little bit similar to this. You can see the effect starts to break down as we kind of change the viewing angle. And this is because this entire technique is really an optical illusion. What's really happening here is we actually have two models that are in the same place, just being rendered differently and at different scales. So we have the regular model, which is rendered using our normal textures and whatever techniques we want to apply to it. And we also have this outer model, which is being rendered with inverse normals and is being rendered completely in black with no shading and no textures whatsoever. So to kind of understand this a little bit better, you kind of need to understand what normals are in graphics and how backface culling actually works. So let's say we have our sphere here. I'm just going to go ahead and draw this on the annotation layer. So each object in 3D graphic is made up of faces. And one of the properties of these faces is they each have a direction, which is just a direction in which they're pointing. And it's really useful to know where a face is actually pointing for a lot of different reasons. For one thing, if you're doing physics simulations, it's easier to understand how objects are going to interact with each other whenever they collide, how they should bounce off of each other. You can use it for lighting, understanding how a certain surface is angled towards a light source, towards the camera, kind of helps you understand how to render that in the actual shader pipeline. It's also used a lot for optimization. So let's say we have a camera here, and we're looking at the cube from this angle. Now for real-time graphics, every second counts. We want to optimize our rendering as fast as we can, and so obviously we want to render just the faces that we can see. And normals give us a really good way to quickly tell which faces are actually facing the camera and might actually be seen and therefore need to be rendered. So for this example here, we have our camera looking at the cube. And if we just wanted to render the faces that are pointing relatively towards the camera, that would mean that this side would be rendered, this side would be rendered. But because these two sides are kind of pointing away from the camera, they would not be rendered. Now, from the camera point of view, it all looks the same, but from an optimization standpoint, we effectively eliminated half of the faces that we actually have to render, meaning that we rendered the scene a little bit faster than we would have otherwise. And this is known as backface culling. Basically, any face that we're seeing the back of or is pointing away from the camera, we just don't render at all to save on time. Now for inverse shell, what we're doing is we are effectively creating a copy of our mesh that is a little bit bigger than our mesh, and we're inverting the normals. So what that's going to look like, let me go ahead and create a new layer here. And we're just going to make that purple just because. So we're going to have another cube that's bigger, that completely encompasses the original sphere. And instead of having the normals facing outward, we're going to have them facing inward. And we're also going to paint this cube entirely black. We're not going to apply any lighting to it, no materials. It's just going to emit a pure black color. And so what this means is that whenever we do our backface culling, what's going to happen is the camera is going to be looking at it. This face is not going to be rendered because it's facing away. This face won't be rendered, but these two back faces will. And so effectively, you're seeing through these front faces, you're seeing the regular model, and then you're seeing these back faces back here, which is exactly what's happening on our regular model. So these faces are, in actuality, are here. But because our camera is over here, they're not being rendered and they're completely see-through. So all we're seeing are these back faces here and our model. And this is what achieves that outline look. We're literally creating a shell of our model using a copy of it. We're painting it completely back. We're inverting the normals, and then we're just drawing the scene as normal. And this is why it's called the inverse shell, because it's an inverted shell of the model itself that is casting this effect. Moving on to how to actually implement this effect in Blender, it's pretty straightforward. First thing we're going to do is we're going to delete the default cube as is tradition, and we're going to go ahead and add Suzanne. Hello, Suzanne. And we're going to add a subdivision surface, just so we have a little bit of a smoother monkey to work with. Apply that, shade smooth, and now we're all set to get to work. So first thing we want to do is actually set up our material. So let's go to the shading tab and go ahead and open the materials button down here on the right. We're going to need this in just a second. So let's go ahead and create a new base material for our monkey. And let's go ahead and change the type to a Toon BSDF. Now, because we're using Eevee and we're not doing anything fancy, you can use whatever shader you want. So if you want to change this to a painting shader or a cell shader, you can, but I'm just going to use a basic Toon shader and with a solid color just for this example. So after we have the base material all set, we're going to go ahead and create a new material and apply it to this model. So we're going to come up here and hit the little plus sign, and that's going to open up another material slot for this model. Now, the main rendering is going to be done with this first material slot, but we're going to need this for the outline later. So go ahead and create a new, and we're going to change this into an emission shader. And we're going to change this color all the way to black. Now, this material isn't actually being applied to our model just yet, just because the model data doesn't have any idea where to put this one. Whenever we actually add the outline, we're going to tell Blender to use this material for it, which is why we're changing it all to black. And while we're here, what we're going to want to do is we're going to enable backface culling, so this way only the front faces are going to be visible. And we're going to go ahead and disable shadows, just so it doesn't mess with the shading on our base model. And with that all done, we can head back into layout mode. And go ahead and enable material preview, just so we can see what our materials are doing whenever we do it the next step. And we're ready to add a shell to our model. To do that, we're going to select our monkey, we're going to add a modifier, and this time we're going to add a solidify modifier. Now, solidify modifier, whenever it's applied to a flat surface, will actually give it a little bit of depth. This is a great way to add a little bit of depth to things like paper or other flat surfaces. Just give them a little bit of depth to set them off. But whenever we apply it to a complete shape like this, it'll actually create a shell around the original model. So if we go ahead and change the offset to 1 and we start increasing the thickness, you can see that the model starts to puff up a little bit. And this is the shell that's actually being created around our model. And this is what we're going to use as our inverse shell to create our outline effect. So now to get the effect we want, first thing we want to do is we're going to come down here to materials, and we want to change the material offset to 1. So this is going to tell it to come over here to the materials tab and take the this material right here. Because the materials are 0 index based, meaning that this first material is material 0, this one is going to be material 1 in the materials tab. So go back to modifiers. Now we're telling it to, okay, whenever we're rendering it, we want to use the first material. And next what we want to do is we want to go to normals, and we want to flip the normals. And this will apply our outline to our model. Now, obviously, this doesn't look that great, so we kind of need to dial the settings in. And if we go for something a little bit subtle like that, we get a nice outline effect for our monkey. So that's the basics on how to achieve this effect, but there's a lot of settings over here that you can actually tweak to kind of change the appearance of the outline and how it actually creates the shell. For example, if you wanted an even thickness, you could select this option right here. So this way, no matter how thick the model is, whenever we increase the thickness, it stays a pretty uniform size, just like this. Another useful option, especially if the shell isn't quite giving you the effect you want, is down here in the thickness clamp. So to kind of demonstrate what this is doing, let's go ahead and turn the normals back on for just a second, so they're facing outwards. So as you can see in areas like here, you can see the model kind of bites into itself as it kind of puffs up a little bit. This clamp here will kind of limit how much that can affect it. So you can kind of limit how much it can get puffed up in a given area. So if we start turning this clamp up, you can kind of see it starts in the recesses as it gets kind of close together. And you can kind of see it kind of limits how much it can get popped up. Kind of go back and forth just like that, kind of playing with it, just to kind of give you an idea. So if you find yourself seeing the outlines aren't really adhering well to the flow of the model, or it's cutting into itself a lot, play around with this clamp value to kind of get a better handle on it. So if we go ahead and turn the outline back on with this clamp value, we can see that it kind of fixes itself really nicely and adheres more to the general shape of the model, especially around this nose area right here. So it is really important to note that the quality of the shell and how much it adheres to the model is going to influence the quality of the actual outline itself. So you can see with these settings, if we turn the clamp off, the nose starts to look a little bit rough around the edges, just because the model isn't really adhering very well to all those different curves, and the general shell itself is just kind of collapsing in on itself. This clamp kind of helps you fix that issue by forcing it to kind of adhere to the topology of the model a little bit more. And that's really the basics of using the solidify modifier to create an inverse shell effect that adds this really nice outline. But there are some cases where the settings in this modifier just really don't adhere to your model very well, or what you want to do with the outline. For example, say we wanted this ear to just always have a really thick outline that's separate from the rest of the model. Like maybe have, a more form-fitting line here, and we want the ears to have a really big outline out here, just kind of accentuating it for some reason or other. There's really no easy way to do that with the solidify modifier, but we can use the solidify modifier to give us a base mesh that we can use to create the shell ourselves. And we're going to add a new vertex group, and we're going to call it shell. Just like that. And now over here in the modifiers, whenever we apply this modifier, it is going to keep both the base model and the newly created shell. And there's an option down here in output vertex groups that we can specify where we want the shell vertices to go. So we can add all of those new vertices that correspond to the shell to a new group for easy selection. So we just come down here and select our new shell vertex group. Now, whenever we apply this modifier and it actually creates those vertices for real, all of those new vertices will go into the shell group that we can use to actually extract it. So if we go ahead and apply this model and we tab into edit mode here, you can see that we now have two sets of vertices, one for the shell and one for our base model. If I can select it, and you can see it. And now if we go back to the data group, we select our shell group and we hit select, we have now selected just the shell part of the model. So now if we hit P, which is the separate hotkey, we can do a separate by selection, which now creates a second model up here, which is just our shell. So if we select this new model and move it around, that is just our shell by itself. So now at this point, we can edit this just as we would any other model. So if we come in here and we just select all these vertices on the top, we can go ahead and move them manually around, something like that, just kind of giving it its own custom outline. And this way, if we found an area that the modifier was giving us a lot of trouble with, or we wanted to go for a specific look in certain areas for our outline, we can just go in and edit this new model and get whatever output we desired. This is a little bit more difficult because we are having to model it ourselves, but this is a good way to get around any problems that the pure modifier workflow may not be able to handle. And so that's really the basics of how to add this effect to your models in Blender. I hope this was useful for you, and thank you so much for watching, and I will see you guys in the next video.